Good evening, sir. We, the group of 4 members, myself, Pranav Kumar Mishra, Anish Jain, Rishabh Mittal, and Bhavesh Kalla, are doing a data science project to predict whether the breast cancer is benign or malignant or not. The things that we will be working and looking upon are the dataset collection and exploration, which includes introduction to problem, the dataset overview, and explaining features of dataset. The third point is pre-processing of dataset. Pre-processing of dataset will include checking for class imbalance problem or removing some redundant features if the redundant features are present by using heat map. And the third one is box plot representation of attributes. The fourth one will be our preliminary analysis, which will be including normalization of dataset and train test splitting. Then comes component analysis. Component analysis will use scaling and normalization, a scatter plot, cumulative variance plot, and the evaluation models that we will be using and working upon are our fitting models, naive Bayes and decision tree model, and the most important one, KNN classifier. And finally, we will have result which will include confusion matrix, and there will be a comparison on the accuracy of the model. Now in the abstract part, we will be talking about of all the known cancers in the world, breast cancer rates are alarming, and they are in very different data which shows that the increase, there is a gigantic increase in the number of cases of breast cancers in India as well as in abroad. Currently, an Indian data which shows that 1 in 22 women develop breast cancer, which on which out of 2 who develop it, one person dies. In machine learning, we will use some classification algorithm like naive Bayes, decision tree, and KNN for breast cancer classification. And we will be comparing these different implementation, and we will be comparing their accuracy, that how much they are accurate. And we have seen that the KNN gives the highest accuracy, which is approx 94%, and then comes the number of decision tree model which gives the accuracy of approx 88%. Now in the data collection and exploration part, in the introduction to problem, we will see that in the breast cancer data set, we will have to see how many number of cases are malignant and how many number of cases are benign. These are some of the attributes of the data set, which includes ID, diagnosis, radius mean, smoothness SE, concavity, concave points, which defines the data set. First, we will read the data set, which is stored in our data.csv file. By reading the data set, we will have columns which are ID, diagnosis. In diagnosis column, we will be finding the diagnosis of breast tissues which are malignant or benign, which then comes radius mean, in which we calculate the mean of distances from center to points of the perimeter. Smoothness mean, which includes mean of local variations in radius length. Concavity mean of severity of concave portions of the contour. And the concave points mean, where mean for number of concave portions of the contour is calculated. And then again comes concavity SE, a standard error for severity of concave portion of the contour, and more dataset features like concave points SE, fractal dimension, radius worst, texture worst. Portion, the pre-processing of dataset will be carried upon by Bhavesh Kalla.
We come to the pre-processing of the dataset. Next, we explore the class imbalance problem. In this problem, the positive class of the dataset is far less than the total number of the other class, that is the negative class of the dataset. So to find this, we check for the class imbalance problem, and we go through by going through this code, we found that there is no class imbalance problem. Here we can see that malignant is the positive class and benign is the negative class. So we found that malignant has approximately 62.74, and that is malignant has 37% and benign has 63%. So we plotted the bar plot of the malignant and benign classes, and we found out dataset is not a class imbalance problem. It is not a class imbalance problem. We find the box plot of the various attributes of the dataset. After going through the code of the box plot. We use the matplotlib library to plot the box plot, and here are the various box plot of the different attributes versus the diagnosis attribute. Here we can see that for every attribute there is standard deviation plot, and mean of the plot is also there in the box plot. Redundant features in the data set. The redundant features were plotted by heatmap. This topic will be carried on. Now after performing exploratory data analysis, we have come to a total of 21 attributes. These attributes can further be reduced by cumulative variance analysis. In this cumulative variance analysis, we find the cumulative sum of all the features of the data set to find a graph that is shown below. Let me see the graph. Here is the graph. In this graph, it is plotted with the number of components versus the cumulative variance. Now, the first two components explain the 0.63% of the cumulative variance of the total data set of the graph. But we see that only 10 components contribute to the major cumulative variance of the data set, and the rest 12 components do not contribute much. So in this principal component analysis, the total number of attributes are reduced to only 10 attributes or 10 components only. Next is the PCA scatter plot. In this PCA scatter plot, we have plotted PCA plot for only n components equals to 2. Here is the code for the PCA scatter plot, and this is the scatter plot showing the principal component 1 along the x-axis and principal component 2 along the y-axis, and this is for plotted for benign and the malignant cases, as we can see in this PCA scatter plot.
Overfitting problem. In overfitting problem, the algorithm works good on the training data but fail when the testing data comes. This is mainly due to the reason that it will start learning from the noise and the outliers of the dataset. Because of this, it will fit well in the training data, but its accuracy will be hindered during the testing phase. To remove this, there is a method called cross-validation. In this, we divide a dataset into the different folds known as cross-folds. Like a dataset is divided into 10 different small dataset, and for each dataset we will build a new model and then calculate the mean accuracy of the ensemble model. Like when we apply the cross validation on the k and n with different values of k ranging from 0 to 30, the accuracy we got is like this. So the maximum accuracy we are getting at the value of 7 nearly. KNN classification algorithm. So we will focus mainly on this algorithm in our project. KNN classification is a lazy algorithm. It means that when a new data point comes, then only it will start its procedure or its working. In this algorithm, when a new data point comes, it will consult all its neighbor, means its nearest k neighbors, and according to its class attributes, it will decide its own class attribute. Like if value of k is 5, then it will consult its nearest 5 neighbor and then it will decide its class attribute. In KNN algorithm, we are iterating to the k value of 1 to 31. It means we are building a total of 31 models, 31 different KNN models, each with the 10-fold cross validation. For each model, we calculate the mean accuracy of the model and then ensemble the total accuracy, thus getting the accuracy of the KNN model. And when we look at the 10 cross validation and the KNN, the total accuracy come out to be 95% approx. It is the best out of all our 3 classification algorithm.
So as my friend has explained the KNN classifier, now Risha Mittal has come to explain naive Bayes. So in naive Bayes classifier, he assumes that the presence of particular feature in a class is unrelated to the presence of any other feature, and it is a probabilistic model. You can say it is a conditional probability model. So in this model, So in this model, let me see the code of Python. So we applied naive-based classifier. So in the first line, we just create the model by using Gaussian NB. We fit the model with the training data set. Now we predict our model, and we see the accuracy of our model by making its confusion matrix. So we can see that our precision values, recall, and F1 score, so for malignant and benign. And this is our heat map of confusion matrix. So we can see here the malignant predicted malignant true predicted malignant are 64, and true malign values are 42. So this gives the accuracy of 93%. Now we come to the decision tree. So in decision tree, what we do, so in decision tree, each internal node represents a test on an attribute. So each branch represents the outcome of the test, and each leaf node represents a class level. So we see the decision nodes. So decision nodes are the root nodes, or can say these typically represented by squares, and the chance nodes, these represented by circles, and these are the end nodes. So we applied decision tree classifier. So in decision tree classifier, we just simply write the function of this, and just to pass a random state, which doesn't matter the value of random state. Now by cross validation score, and by taking mean of that, we found the accuracy for decision tree model, which is 89.9% comes. So is okay. So we come to the conclusion. So in conclusion, after building different classification models, namely KNN, decision tree, and naive Bayes, we conclude that KNN has the best accuracy out of all three. And this is the confusion matrix of KNN for benign and malignant, as we have seen. This is the naive Bayes confusion matrix of naive Bayes, and these are benign and malignant. So we just compare our accuracy for the models, different models. So for KNN it is 95.83, decision tree is 89.9, and naive Bayes is 93%. And at the last, we just do the accuracy plot for these three, and our conclusion is that